An extraordinary event occurred after 3IATLAS vanished behind the Sun. The object has now reappeared, and what astronomers are observing is far more puzzling than anyone could have expected. When the object emerged from solar conjunction, it was captured by telescopes again, and what they saw defied all expectations for objects coming from beyond our solar system. The first fresh glimpses were obtained from Lell Observatory on the night of November 8th, revealing a comet that, quite simply, shouldn't behave the way it does. According to everything we know about interstellar objects, it's an anomaly. While we on Earth were watching and waiting, telescopes at the Discovery Channel Observatory in Arizona picked up a faint blur rising above the northeastern sky. For 8 days, 3IATLAS had been completely obscured, hidden behind the blinding glare of the sun. But now it has returned, and it's what astronomers are uncovering in its wake that is causing such a stir. They're not sleeping much. They're not ready to move on, because the surface of this object, this messenger from another part of the galaxy, is coated with something we've never seen before. Not just dust, not just frozen gases, but a layer of organic compounds some 15 to 20 meters deep. What makes this so astonishing is where those compounds seem to have formed, not near a warm young star, not in the swirling cloud of a new solar system, but in the deep cold expanse of interstellar space, accumulated over billions of years of solitary drifting between the stars. Just think about that. Every observation we make, every spectrum we collect, isn't showing us untouched material from a distant planetary system. Instead, we're looking at something shaped by the vast emptiness between stars, something forged not in the cradle of planets, but in the silence of the galaxy itself. We're peering into the past, into a shell sculpted over billions of years by the relentless bombardment of galactic radiation, long before our own sun ignited. Belgian and American scientists fed the data through computer simulations. The result overturned much of what we thought we understood about objects from beyond our solar system. These simulations revealed that 3IATLAS has been exposed to cosmic rays for anywhere between 3 and 11 billion years. These rays, hurled across space by exploding stars and colliding black holes, have dug deep into the comet's surface, fracturing simple molecules, building elaborate carbon structures, and then dismantling them again. This cycle has unfolded like a vast interstellar forge, one that is never shut off. But then things start to drift into unfamiliar territory. The chemical fingerprint of 3IATLAS looks nothing like any comet we've ever examined. Carbon dioxide dominates its emissions, 7.6 times more than water. That alone is striking.
Since comets are expected to be largely composed of water ice, dirty snowballs drifting through space, this one barely fits that picture. Spectral analysis shows elevated carbon monoxide and an unusually red reflection spectrum, suggesting an organic layer envelops its surface. But even that isn't the strangest part. What truly rattles expectations is in the metallic fingerprint. The ratio of nickel to iron matches engineered alloys, not the cosmic dust we typically encounter. Even more startling, the nickel-to-cyanide ratio is magnitudes higher than any other comet, including Borisov, the previous known interstellar visitor. Some scientists now estimate that the odds of all these features occurring naturally are less than 1%. Then there are the polarization measurements. They're not just unusual, they're extreme. The comet displays negative polarization at levels no comet in history has shown. That's not a small deviation, it's a statistical outlier. When light scatters off the cloud of dust and gas surrounding 3IATLAS, it doesn't behave the way it's supposed to. It behaves in a way no existing models can predict. And we haven't even touched on the orbit. It's moving on a retrograde path, yet aligned within just 5 degrees of the ecliptic, the thin plane along which the planets orbit the sun. Its trajectory cuts right through the solar system with uncanny precision, swinging past Mars, Venus, and Jupiter. Its closest approach to the sun, its perihelion, occurred at the exact moment Earth was positioned behind the sun, unable to observe it. The statistical chance of these events aligning? Just 0.2%. Combine the timing and geometry, and the total likelihood drops to an almost impossible 0.005%. Then came July and August, when something appeared that bent the laws of physics. Observers reported a jet, an anti-tail, not trailing away from the sun as we'd expect, but pointing straight toward it. Not a trick of perspective, but a genuine outflow of material, defying known cometary behavior. The peer-reviewed studies were published, the measurements confirmed, but the physics behind it all is still a mystery. And as 3IATLAS drew closer to the Sun on October 29th, space-based solar observatories such as Stereo, SOHO, and GOES-N1 recorded a sudden explosive brightening. It glowed more intensely in certain wavelengths than the Sun itself. Imagine that! A frozen fragment from interstellar space reflecting more blue light than our star. But there's something else that excites physicists. This close encounter created an opportunity to test Einstein's general relativity. According to the theory, the Sun's gravity should bend light from 3IATLAS by 0.27 arcseconds, an angular separation that's subtle but measurable. And that's exactly what ALMA, the Atacama Large Millimeter Array, detected. The comet appeared 4 arcseconds from where it should have been.
Some of that offset could be due to gravitational lensing, but there's another possibility, one that's even harder to explain: non-gravitational acceleration. The comet changed the speed not because of gravity, but from something else entirely. If that's caused by jets of gas erupting from its surface, it should have shed at least 15% of its mass, roughly 5 billion tons of gas and debris. That's not something that can go unnoticed. As we move deeper into the mystery of 3IATLAS, new layers of complexity begin to surface. While astronomers continue to monitor this unusual object, they have begun to question everything they thought they knew about interstellar comets. The idea that 3IATLAS is simply another comet seems increasingly unlikely. Its strange behavior, coupled with the unexplainable acceleration and anomalous emissions, suggests that this object may be far more than just a wayward chunk of ice and dust. One of the most perplexing aspects of 3IATLAS is its non-gravitational acceleration. As mentioned before, this object is not behaving the way we expect from a comet. If the acceleration was the result of typical outgassing, we would expect to see visible signs, such as a coma or tail, as gas and dust are rejected from the surface. But instead, 3IATLAS is behaving like something we've never encountered. The acceleration is strong enough that it has noticeably changed its trajectory, making it one of the most interesting objects in space at the moment. Another anomaly that has caught the attention of scientists is the object's polarization measurements. When light scatters off a comet's dust and gas, we typically see a pattern of light and dark areas that reveal important information about its surface composition. However, 3IATLAS is displaying a negative polarization effect that no comet has shown before. This is a significant departure from what we have come to expect from comets, and it adds another layer of mystery to the object's behavior. And then there is the object's orbit. The retrograde path it is taking is unlike anything we've seen before in a comet. 3IATLAS is moving in a direction opposite to the typical movement of objects in the solar system, yet despite this strange trajectory, it is aligned with the ecliptic plane, only 5 degrees off. This highly precise alignment, combined with its uncanny passage through the solar system, further suggests that 3IATLAS is not a simple comet. Its path appears to be purposeful, almost as though it is navigating through space with intention. One of the most baffling aspects of 3IATLAS is its ability to bend light, an effect predicted by Einstein's theory of general relativity. As the object passed close to the Sun, astronomers expected the Sun's gravity to cause some bending of light coming from the comet. However, the level of bending that was observed was far greater than anticipated. The object appeared 4 arcseconds away from where it should have been, and this deviation has sparked a number of theories about the true nature of 3IATLAS. Could it be that this object is moving with some form of propulsion, allowing it to alter its speed and trajectory? If so, what could be causing that propulsion? The idea that 3IATLAS is a probe deliberately altering its course and accelerating as it travels through space is something that scientists can no longer ignore. As we continue to gather more data, the possibility that 3IATLAS is not a natural comet becomes increasingly plausible. The unique combination of factors, its strange acceleration, unusual emissions, peculiar orbit, and the bending of light points to the likelihood that 3IATLAS could be a piece of advanced technology. While it is still too early to say for certain, the growing body of evidence suggests that we may be dealing with something far more extraordinary than a typical comet. The potential implications of this discovery are enormous. If 3IATLAS is indeed a probe, it would be the first definitive evidence of extraterrestrial technology. This would be a groundbreaking discovery with profound implications for our understanding of the universe and our place within it. Of course, we must also acknowledge the possibility that 3IATLAS is simply an unusually active comet. The peculiarities we are observing may simply be a result of some unknown process occurring in the comet's core. But given the growing number of anomalies surrounding the object, this explanation seems less likely with each passing day. The strange nature of 3IATLAS has captivated scientists, and it's clear that they are not ready to let go of the idea that we are witnessing something far more extraordinary than a typical comet. The next few months will be crucial in determining the true nature of 3IATLAS. As the object continues its journey through the solar system, astronomers will be closely monitoring its behavior, watching for any new signs that could provide further clues about its origins and purpose. Spectroscopic analysis will continue, and new data will be gathered on its emissions, its trajectory, and its interaction with the solar wind. Radio telescopes will be listening for any unusual signals, and astronomers will be studying the object's surface composition in more detail. It's important to note that the investigation of 3IATLAS is not just about confirming whether it is a comet or a probe. It's also about understanding the physics behind its behavior. The strange acceleration, the unusual polarization, the bending of light – these are all phenomena that challenge our understanding of how objects move through space. They force us to rethink our models of interstellar objects and to consider the possibility that we are missing something fundamental in our understanding of the universe.
As we continue to observe 3IATLAS, it's clear that we are on the brink of a discovery that could change everything we know about space and technology. Whether the object is a comet or a piece of alien technology, it is offering us a glimpse into the unknown. The study of 3IATLAS may ultimately lead us to a better understanding of the universe and the forces that govern it. As we advance in our study of 3IATLAS, it's becoming evident that the object's behavior is far from ordinary, and it challenges our understanding of space and celestial mechanics. As the object approaches Earth, astronomers are eagerly collecting data, analyzing every aspect of its motion, emissions, and composition. Every new piece of information brings us closer to answering the fundamental question: what exactly is 3IATLAS, and what is its purpose? One of the key aspects that still requires clarification is the object's unusual acceleration. It's important to note that 3IATLAS is not behaving like any comet we've observed before. The strength of its non-gravitational acceleration is much higher than what we would expect from a typical comet. This has raised several important questions. Why is it accelerating so much? Is it simply a result of outgassing? Or could there be another explanation? And if it's not natural outgassing, what other forces could be at work? The standard explanation for a comet's acceleration is that it results from the sublimation of volatile materials as the comet approaches the Sun. The heat from the Sun causes ice on the comet's surface to evaporate, which produces gas and dust. This process propels the comet in the opposite direction. However, for 3IATLAS, the amount of acceleration observed is far stronger than what we would expect from this process alone. In fact, it's strong enough to significantly alter the object's velocity and trajectory. This hints at the possibility that there could be something else driving this acceleration, something other than simple outgassing. The fact that 3IATLAS is accelerating at such a rate is one of the primary reasons why astronomers are so fascinated by it. If the acceleration continues, the object could eventually come closer to Earth than we originally expected. In fact, calculations suggest that if the acceleration persists, 3I-ATLAS could make its closest approach to Earth on December 19, 2025. But what could be causing this acceleration? Could it be that 3I-ATLAS is actively adjusting its trajectory? This idea, while speculative, is gaining traction among some researchers who believe that the object might be more than just a simple comet. In addition to the mysterious acceleration, there's the issue of the signals that have been detected coming from 3I-ATLAS. These faint signals, observed at a frequency of 1.4 gigahertz, have raised the possibility that this object could be more than just a natural celestial body. The
4 gigahertz frequency lies within the waterhole of the electromagnetic spectrum, a region that has been of great interest to astronomers searching for extraterrestrial signals. The fact that 3I class ALS is emitting signals at this frequency raises the question, could this be a deliberate attempt to communicate? If so, it would be the first time we've ever detected a signal from an interstellar object that could be interpreted as intentional. However, while the detection of these signals is intriguing, it's important to remain cautious. These signals have not been independently confirmed, and it's still unclear whether they are truly deliberate or if they could be caused by some other, as yet unidentified, phenomenon. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, and while many signals have been detected, none have yet been definitively linked to an intelligent source. The signals from 3I class ALS may or may not be the breakthrough we've been waiting for, but they certainly add another layer of mystery to this already enigmatic object. What makes 3I class ALS so fascinating is not just the possibility of it being a probe or a communication attempt from an alien civilization, it's the sheer mystery of the object itself. Its composition, behavior, and trajectory defy many of the expectations we have for interstellar objects. Scientists have spent years developing models to predict the behavior of comets, asteroids, and other objects in space, but 3I class ALS is proving to be a real challenge. Its strange acceleration, unusual emissions, and mysterious signals suggest that there is much more to this object than we first imagined. As the investigation continues, astronomers are gathering new data that will help to refine our understanding of 3I class ALS. Spectroscopic analysis is playing a crucial role in this process. By examining the light reflected off the object, scientists can learn about its composition and identify the elements and compounds that make up its surface. If 3I class ALS is a comet, we would expect to see the familiar chemical signatures of water ice and carbon-based molecules. However, the data so far suggests that 3I class ALS is different. Its emissions are dominated by carbon dioxide, with much less water than we would expect. The presence of carbon dioxide in such large quantities is particularly puzzling. While some comets are known to release carbon dioxide as they approach the Sun, the amounts observed from 3I class ALS are far higher than expected. This raises further questions. Is 3I class ALS a comet, or is it something entirely different? If it is not a comet, then what is it? Could it be an artificial object sent from another star system, or could it be the product of some unknown natural process? These are the questions that scientists are grappling with as they continue to study the object.
As mentioned earlier, 3IATLA is moving on a retrograde path, meaning it is traveling in the opposite direction of most objects in the solar system. Yet, despite this unusual movement, the object is still aligned with the ecliptic plane, only 5 degrees off. This precise alignment is highly unusual and suggests that 3IATLA is not just a random interstellar object. Its trajectory seems too deliberate, as though it is moving through the solar system with purpose. The idea that 3IATLA is a probe intentionally directed toward Earth is gaining traction, but it is still speculative. As we continue to collect more data on 3IATLA, the mystery deepens. Whether it is a comet, a probe, or something else entirely, the object's strange behavior challenges everything we thought we knew about interstellar objects. The next few months will be crucial in determining the true nature of 3IATLA. Scientists will continue to monitor the object's acceleration, its emissions, and its trajectory. They will be looking for any new signs that could help to solve this cosmic puzzle. The closer 3IATLA gets to Earth, the more we will learn about its origins and its purpose. As we continue to track 3IATLA, we're approaching a crucial moment in its journey. The object's closest approach to Earth is scheduled for December 19, 2025. This will mark a critical point in our ability to observe and study 3IATLA in detail. Up until now, the object has been an enigma, and every new piece of data adds another layer of complexity. But with the approaching closest approach, astronomers will have an unprecedented opportunity to capture even more detailed observations. This will be a pivotal moment in our understanding of this interstellar visitor. Will 3IATLA continue to exhibit the same unusual behavior? Will its acceleration persist, bringing it closer to Earth? Or will it slow down? What new phenomena will we observe as the object gets closer to the Sun and the Earth? These are the questions that scientists are eagerly awaiting answers to. The closer 3IATLA gets, the more we will learn about its nature. Already, its strange acceleration has made it clear that this object is far from ordinary. But it's not just its acceleration that's causing scientists to scratch their heads. Its composition, its emissions, and the way it interacts with the solar wind are all completely unlike anything we've ever seen before. One of the key tools that will help scientists gather more information is spectroscopy. Spectroscopic analysis allows astronomers to study the light reflected off 3IATLA and determine its chemical composition. By examining this light, scientists can identify which elements and compounds are present on the surface of the object. If 3IATLA is a typical comet, we would expect to see certain chemical signatures, primarily water ice and carbon-based molecules. However, the data so far suggests that the object is not behaving like a typical comet.
Instead, its emissions are dominated by carbon dioxide, with much less water than expected. This raises important questions. Is 3IATLAS truly a comet, or is it something else entirely? The discovery of such unusual emissions has led to speculation that 3IATLAS may be something far more complex. Could it be a probe intentionally directed toward Earth from another star system? Could it be a piece of technology deliberately altering its course as it passes through our solar system? While these ideas remain speculative, the data we've gathered so far makes them seem less far-fetched. The object's strange behavior, from its unusual acceleration to its odd emissions, points to the possibility that we're dealing with something extraordinary. In addition to spectroscopic analysis, radio astronomy will also play a vital role in the ongoing investigation of 3IATLAS. As mentioned earlier, faint signals at 1.4 GHz have been detected emanating from the object. This frequency lies within what is known as the waterhole of the electromagnetic spectrum, a region that is often considered ideal for interstellar communication. The fact that 3IATLAS is emitting signals at this frequency raises the possibility that the object is attempting to communicate with us. If these signals are intentional, it would be a groundbreaking discovery, proof that we are not alone in the universe. However, it's important to remain cautious until these signals can be independently verified. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, and while many signals have been detected, none have yet been definitively linked to an intelligent source. As of now, the signals from 3IATLAS remain an intriguing mystery. While the possibility of extraterrestrial communication is exciting, it's important to consider all potential explanations for the object's behavior. 3IATLAS could still be a natural object, albeit one exhibiting unusual characteristics. We may be dealing with a comet that has been altered by cosmic forces in ways that we don't fully understand. The possibility that 3IATLAS is a probe remains speculative, and we cannot jump to conclusions based on the limited data we have. The truth may lie somewhere in between. As we approach the moment of closest approach, the scientific community will be paying close attention to the data coming in from telescopes and observatories around the world. The coming months will be critical in determining the true nature of 3IATLAS. The data we gather could confirm that it's a strange but natural object, or it could provide evidence that we're dealing with something much more extraordinary. Regardless of the outcome, the study of 3IATLAS will have lasting implications for our understanding of the universe. This object, with its unusual acceleration, odd emissions, and possible communication signals, is forcing us to reconsider our models of interstellar objects.
It's reminding us that the universe is vast and filled with mysteries that we have yet to comprehend. In many ways, 3IATLAS is a reminder that we are still in the early stages of exploring the cosmos. We've only just begun to scratch the surface of what's out there, and this object is offering us a rare glimpse into the unknown. As we continue to study 3IATLAS, we may discover things that will completely alter our understanding of space, physics, and even the potential for life beyond Earth. The next few months will be critical in unraveling this mystery, and the world will be watching closely as we make new discoveries and push the boundaries of human knowledge. As we approach the final stages of 3IATLAS's journey through our solar system, the stakes couldn't be higher. The scientific community is bracing itself for what could be a groundbreaking discovery, whether it's a comet with an unusually strong acceleration, a probe from another civilization, or something entirely different. The importance of these findings goes beyond the object itself. They could redefine our understanding of space and our place in the universe. The next few months will be critical in unraveling this mystery, and the world will be watching closely as we make new discoveries and push the boundaries of human knowledge. One of the central elements of the investigation is the acceleration of 3IATLAS. Over time, we've observed this object gradually changing its velocity in a way that cannot be explained by gravity alone. Normally, a comet's speed is adjusted through the sublimation of volatile materials from its surface, a process that creates a small yet noticeable push. However, 3IATLAS's acceleration is much stronger than what would be expected from this process. The fact that it is continuing to gain speed at such a high rate raises the possibility that something else is driving its movement. Could the object be undergoing some kind of propulsion that we haven't observed before? It's a question that has led some researchers to speculate that 3IATLAS might not be a natural object at all. If it is indeed being propelled by an external force, could it be the result of intelligent design? The idea that 3IATLAS might be a probe, either sent by another civilization or constructed by some unknown force, opens up a whole new realm of possibilities. While this remains speculative, the evidence so far, especially its unusual acceleration, could suggest that we're dealing with something far more complex than a simple comet. What makes this possibility even more intriguing is the detection of signals at 1.4 gigahertz, a frequency that is considered ideal for long-distance communication. While it's still too early to confirm whether these signals are intentional or just a natural byproduct of the object's journey, the mere possibility is enough to capture the imagination.
Could these signals be an attempt to communicate with us? Or is 3IATLAS simply emitting random radiation as it passes through the solar system? This is one of the most critical questions that astronomers will be grappling with in the months ahead. If these signals are indeed a form of communication, it would be the first evidence of extraterrestrial intelligence in human history. It would be a discovery of unimaginable proportions, one that would not only confirm the existence of other civilizations, but also show that they possess the technology to send probes across interstellar distances. If 3IATLAS is a probe, it would suggest that advanced civilizations have been exploring the cosmos for much longer than we have, perhaps even sending these objects on purpose to study other star systems. However, the possibility of extraterrestrial technology is just one of many theories that must be considered. While the signals are compelling, they have not yet been independently verified, and it's important to approach the idea of alien communication with caution. There could be other explanations for the data we are seeing, and scientists will need to gather more information before drawing any definitive conclusions. For now, we can only speculate about the true nature of the signals. Regardless of whether 3IATLAS is a probe or a comet, the object is providing us with an incredible opportunity to study interstellar space. The object's unusual behavior is forcing scientists to rethink many of their assumptions about how objects behave when traveling through the cosmos. It's a reminder that the universe is far more complex and mysterious than we ever imagined. The discoveries we make about 3IATLAS will not only enhance our knowledge of space, but could also lead to advancements in technology and physics. One of the most exciting aspects of the investigation is that we are studying 3IATLAS in real time. We have the rare opportunity to observe an object from another star system as it passes through our solar system. This is the first time that humanity has been able to study an interstellar object up close, and the data we gather will shape our understanding of the cosmos for years to come. As we continue to observe 3IATLAS, we are pushing the boundaries of what we know about space, time, and the potential for life beyond Earth. The coming months will be critical in determining the true nature of 3IATLAS. As it makes its closest approach to Earth in December 2025, astronomers will have the chance to gather more data and refine their understanding of the object's behavior. Will it continue to accelerate? Will its emissions change? Will we detect more signals? These are the questions that will guide the research in the coming months, and the answers could reveal more than we ever thought possible. As the investigation progresses, we are reminded that the universe is full of surprises.
3IATLAS is just the latest in a long line of mysteries that have sparked our curiosity about the cosmos. Whether it's a comet, a probe, or something else entirely, this object has captured the attention of scientists, researchers, and the public alike. It is forcing us to rethink our understanding of space and our place within it. The discoveries made during the study of 3IATLAS will have lasting implications for the future of space exploration and our search for life beyond Earth. The study of 3IATLAS is not just about understanding one object, it's about challenging the very foundation of our knowledge of space and celestial bodies. Each new observation, each new piece of data, is forcing scientists to reconsider their assumptions about how objects behave when traveling through the vast expanse of interstellar space. The more we learn about 3IATLAS, the more we realize that it represents a unique opportunity to explore the unknown and possibly rewrite the rules of astrophysics as we know them. The question of whether 3IATLAS is a comet, an alien probe, or something else entirely remains at the forefront of this investigation. The data we have collected so far suggests that this object is unlike any comet or interstellar object we've studied before. Its strange acceleration, unusual emissions, and unexpected behavior challenge our understanding of these objects. Whether 3IATLAS is a naturally occurring comet or a man-made probe sent across the stars, its behavior is forcing us to rethink everything we thought we knew about the cosmos. One of the key aspects of this investigation is understanding the physical processes behind 3IATLAS's unusual behavior. The non-gravitational acceleration, which is far stronger than we would expect from outgassing alone, is a critical point of interest. It's possible that this acceleration could be caused by an unknown phenomenon, one that could have significant implications for our understanding of space. Could 3I-ATLAS be using some form of advanced propulsion, one that we haven't yet discovered or understood? Or could it be harnessing the forces of the cosmos in a way that defies our current knowledge of physics? In addition to its acceleration, the object's strange emissions are another key area of investigation. As previously mentioned, the primary emission from 3I-ATLAS is carbon dioxide, with very little water detected in its composition. This is highly unusual for a comet, as most comets are expected to have a high concentration of water ice. The presence of carbon dioxide suggests that 3I-ATLAS may be a much more complex object than a simple icy body. It's possible that its surface contains materials that have been altered by cosmic radiation, or that the object itself is made of materials that are not typically found in comets. Furthermore, the detection of faint signals at 1.4 gigahertz adds another layer of complexity to this puzzle.
If these signals are intentionally emitted, it could suggest that 3I-ATLAS is not a natural object, but rather a piece of technology. The fact that these signals lie within the water hole of the electromagnetic spectrum, a frequency range that is often considered ideal for extraterrestrial communication, raises the intriguing possibility that 3I-ATLAS could be trying to communicate with us. While the idea of an alien probe may sound far-fetched, we must remember that the possibility cannot be entirely dismissed. The unique behavior of 3I-ATLAS has led some researchers to suggest that the object could be a probe sent by an advanced civilization. If this is the case, it would be one of the most significant discoveries in the history of human space exploration. It would confirm that we are not alone in the universe, and that other intelligent civilizations may have been exploring the stars long before we began our own journey into space. However, despite the excitement surrounding these theories, it's important to approach the situation with caution. The data we have so far is intriguing, but it is not yet conclusive. There are still many unanswered questions, and more observations will be needed before we can draw any definitive conclusions. It is possible that 3I-ATLAS is simply an unusually active comet, exhibiting behavior that we don't fully understand. But it is also possible that this object is something far more extraordinary, a harbinger of discoveries that could change the course of human history. The next few months will be critical in determining the true nature of 3I-ATLAS. As the object continues its journey through the solar system, astronomers will be keeping a close watch, collecting more data, and refining their understanding of its behavior. The closer it gets to Earth, the more information we will have about its composition, its trajectory, and its emissions. With each passing day, we move closer to answering some of the most profound questions in science. What exactly is 3I-ATLAS? Is it a comet, an alien probe, or something else entirely? As we continue to observe this object, we are not only learning about 3I-ATLAS itself, but we are also learning more about the universe and our place within it. The discoveries we make during this investigation could have far-reaching implications for our understanding of space, time, and life beyond Earth. Regardless of the outcome, the study of 3I-ATLAS will have a lasting impact on the field of astronomy. This object has already forced us to reconsider our understanding of interstellar objects, and it may ultimately lead to new breakthroughs in physics and space exploration. Whether it's a comet, a probe, or something else, 3I-ATLAS is offering us a glimpse into the unknown, and the answers we uncover will shape the future of space science for years to come.
For the scientific community, it represents a rare opportunity to explore something completely new, something that challenges our current understanding of space and the objects within it. The object's strange acceleration, its unusual emissions, and the possibility of it being an interstellar probe, these factors make 3I-ATLAS one of the most significant discoveries in recent astronomical history. But as the investigation deepens, we are confronted with the fact that many of the questions raised by 3IATLAS may not have straightforward answers. The key challenge that scientists are facing is the object's behavior. The traditional models we have for understanding comets simply don't apply here. Typically, comets are predictable in their behavior. We know that as they approach the sun, they release gases and dust, forming a tail or coma. These gases propel the object slightly, causing it to accelerate, but this acceleration is usually small and consistent. However, 3IATLAS's acceleration is anything but predictable. It is much stronger than what we would expect from outgassing alone. This raises the possibility that there is something else at play, something we have yet to fully comprehend. Could this object be using a form of propulsion that we are not yet familiar with? It's a question that has been raised by some researchers, and it's one that is becoming increasingly important as we gather more data. If 3IATLAS is not simply a comet, but an object with purpose, it would change everything we know about interstellar objects and their potential role in the universe. The idea that 3IATLAS might be a probe sent by an advanced civilization, deliberately altering its course through space, is both exciting and unsettling. We've long speculated about the existence of extraterrestrial intelligence, but the discovery of a probe from another star system would be a game changer. It would provide irrefutable evidence that we are not alone in the universe. While this theory remains speculative, it is important to consider all the possibilities. The signals detected at 1.4 gigahertz, the unusual emissions of carbon dioxide, and the object's strange behavior all point to the possibility that 3IATLAS is more than just a comet. If the signals are confirmed to be intentional, it would suggest that this object is communicating with us, or at least trying to. This would be the first time we have detected a potential signal from an extraterrestrial source. While we can't yet confirm the origin of the signals, the fact that they are at the right frequency to be used for long-distance communication adds another layer of intrigue. However, before jumping to conclusions, it is important to remember that the evidence is still not conclusive. The signals could be caused by some unknown natural phenomenon, or they could be the result of some other cosmic process that we don't yet understand.
As exciting as the possibility of alien communication is, we must proceed with caution. We have seen many instances in the past where signals were detected only for them to turn out to be natural in origin. Until the signals from 3IATLAS can be independently verified, we cannot rule out the possibility that they are simply an anomaly. The upcoming months will be critical in determining whether these signals are intentional, and if so, what they might mean. In the meantime, scientists will continue to monitor 3IATLAS, collecting data and refining their theories. The closer the object gets to Earth, the more information we will have to analyze. The next few months will be crucial in answering the questions that have captivated the scientific community. Is 3IATLAS a comet, an alien probe, or something else entirely? And what will its continued journey through our solar system reveal about the nature of interstellar objects? It's worth remembering that 3IATLAS is not the only interstellar object to pass through our solar system. In 2017, astronomers detected Oumuamua, a similarly unusual object that sparked a great deal of debate. While the debate around Oumuamua was mostly centered on its odd shape and trajectory, 3IATLAS presents a different set of challenges. It's not just its path that is strange, it's the way it behaves. From its strange acceleration to the unexplainable emissions, 3IATLAS is forcing us to think outside the box. But even if 3IATLAS turns out to be just an unusual comet, it will still be a significant discovery. The object's unique behavior is providing us with an opportunity to learn more about the nature of interstellar objects and the forces that shape them. It's a reminder that the universe is far more complex than we can fully comprehend, and that there is still much to discover. Whether 3IATLAS is a comet, a probe,
or something else entirely, the investigation into its origins and purpose will have lasting implications for our understanding of space, time, and the potential for life beyond Earth. As we approach the final stages of observing 3IATLAS, we are reminded of the vast unknowns that still exist in our understanding of space. The mystery surrounding this object continues to unfold, and every new piece of data raises more questions than answers. What began as a routine observation of an interstellar object has now turned into one of the most intriguing and important investigations in modern astronomy. The scientific community is eagerly awaiting the final conclusions that will emerge from this study, but even now, the significance of 3IATLAS is undeniable. Whether it is a comet, a probe, or something else entirely, the data collected from this object will provide us with insights into the very nature of the cosmos.
It is not just about understanding 3IATLAS itself. It is about understanding the forces and phenomena that govern interstellar space. It's about pushing the boundaries of human knowledge and discovering that, perhaps, there is far more to the universe than we ever imagined. As 3IATLAS continues its journey through the solar system, we will be closely monitoring its behavior, emissions, and acceleration. The closer it gets to Earth, the more data we will be able to collect, and the more we will learn about its true nature. Will its acceleration continue, bringing it even closer to Earth, or will it slow down as it moves farther away? Will we detect any more signals? And if so, what will they reveal? These are the questions that will shape the next phase of the investigation. What makes this moment in time so exciting is that we are witnessing history being made. The possibility that 3IATLAS could be an artificial object sent from another civilization challenges everything we know about life beyond Earth. While the idea is still speculative, it opens up a whole new realm of possibilities. The idea that we might be on the verge of discovering extraterrestrial intelligence is both exhilarating and humbling. But even if 3IATLAS turns out to be a natural object, it will still be a major discovery. The scientific community will learn a great deal from this object, and the knowledge gained from its study will shape our understanding of the universe for years to come. The next few months will be critical in answering these questions. As the object makes its closest approach to Earth, astronomers will have the chance to gather the most detailed data yet. The goal is to confirm the object's acceleration, analyze its emissions, and determine its true composition. This will allow scientists to refine their theories and draw conclusions about 3IATLAS's origins and purpose. Regardless of what the final answer turns out to be, the study of 3IATLAS will have profound implications for the future of space exploration. It will encourage further research into interstellar objects and inspire new technologies to explore the cosmos. This is just the beginning of a new era in space science, and the discoveries made during the study of 3IATLAS could open the door to an entirely new field of inquiry. But what if the investigation leads us to a conclusion that we never expected? What if 3IATLAS turns out to be something even more extraordinary than we imagined? What if the signals are real and the object is indeed a probe from another civilization? The possibilities are endless, and that's what makes the investigation so exciting. The unknowns are vast, and each new observation brings us one step closer to uncovering the truth. In the end, the study of 3IATLAS is not just about the object itself. It's about the broader implications of discovering something that challenges our understanding of the universe. It's about exploring the unknown and pushing the boundaries of human knowledge. Whether the object is a comet,
an alien probe, or something else entirely. Its discovery has sparked a global conversation about the nature of life beyond Earth, the forces that shape the cosmos, and humanity's place in the vast expanse of space. What makes 3IATLAS so intriguing is the way it defies traditional explanations. If it were simply a comet, its behavior would likely be more predictable. The fact that it is exhibiting such unusual features, its unexpected acceleration, anomalous emissions, and possible signs of communication, forces us to reconsider our assumptions about space objects and their capabilities. It suggests that there is still much we don't understand about the forces at work in the cosmos. If 3IATLAS is indeed a comet, albeit one with bizarre characteristics, it would still provide us with an unprecedented opportunity to study interstellar objects. It would allow us to observe how a body from another star system interacts with the environment of our solar system. But if it turns out that 3IATLAS is something more, perhaps an artificial object or a probe, then the implications would be far-reaching. It would mark a defining moment in the history of space exploration and potentially confirm that we are not alone in the universe. As the object continues its journey, it will undoubtedly reveal more of its secrets. Every observation, every piece of data brings us closer to answering the fundamental questions: what is 3IATLAS? What is its purpose? Why is it behaving in ways that defy conventional understanding? And what, if anything, can we learn from this encounter that will shape the future of our exploration of space? In the end, the study of 3IATLAS is not just about understanding a single object. It is about expanding the limits of our knowledge and exploring the unknown. The mysteries surrounding 3IATLAS challenge our current understanding of the universe, forcing us to rethink the very nature of interstellar travel, celestial bodies, and the potential for life beyond Earth. As we continue to observe and analyze 3IATLAS, we are reminded that there is so much more out there waiting to be discovered.